Alright guys, welcome aboard. Today I'm going to be tackling the day 4 in this Advent of Cyber from TryHackMe 2024. So yeah, let's just get through the room. This is just a walkthrough video. I'm not going to be going through that. At least I'm going to try to solve it on my own if I get stuck, which haven't happened in these last 3 days. Although the last day, the day 3, I had some issues trying to basically find the vulnerability. It took me a bit of time, but yeah, we managed to do that. Okay, so let's day 4. I'm all atomic inside. Okay, SOC mass is approaching, and the town of Warebills started preparations for the grand event. Glitch, a quiet, talented security SOC mass engineer, had a hunch that this year's celebrations would be different. With looming threats, he decided to revamp the town's security defenses. Glitch began to fortify the town's security defenses quietly and meticulously. He started by implementing a protective firewall, patching vulnerabilities, and accessing endpoints to patch for security vulnerabilities. As he worked tirelessly, he left breadcrumbs, small traces of his activity. So, unaware of Glitch's good intentions, the SOC team spotted anomalies, logs showing admin access, escalation of privileges, patch systems behaving differently, and securing tools triggering alerts. The SOC team misinterpreted the system modifications as a sign of an insider threat or a rogue attacker and decided to launch an investigation using the ATT&CK Framework. Okay. So the learning objectives here are learn how to identify malicious techniques using the MITRE ATT&CK framework, learn about how to use atomic red team tests to conduct attack simulations, understand how to create alerting and detection rules from the attack tests. Okay. Connecting to the machine. So before moving forward, review the questions in the connection card below. Do I need to start AttackBox today? No. Do I need to start VM today? Yes. Is there a split screen available? Yes. Am I given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes, we are given. So let's start this already. Since they're going to be providing us with credentials, I want to basically connect to the VPN, right? Okay, that's done. And this is booting up. If the virtual machine isn't available, use the show split view button on the top page. If you wish to connect to the machine via RTP, use the credentials below. I mean, I might use the connection via RTP, but I might just as well use it here, right? So the username is administrator, password emulation 101, and then the IP, this is loading still. Okay, so the VM has Atomic Red Team and Sysmon installed. Oh, I see. This will allow us to emulate an attack using TTPs described in the MITRE ATT&CK framework. So the detection gaps. While it might be the utopian dream of every blue teamer, we will rarely be able to detect every attacker step in an attack kill chain. Okay, this is a reality that all blue teamers face. There are gaps in their detection, but worry not. These gaps do not have to be the size of black holes. There are things we can do to help make these gaps smaller. Okay. Detection gaps are usually for one of two main reasons. Security is a cat and mouse game. As we detect more, the threat actors and red teamers will find new sneaky ways to thwart our detection. We then need to study these novel techniques and update their signature and alert rules to detect these new techniques, right? So the cybersecurity field is always evolving, right? Even attackers are just improving their ways to actually compromise systems. So the tracks and basically the blue team needs to also update what information they're going to be recovering, what they're going to be paying attention to, and just always learning. That's kind of why I like cybersecurity. It's one of those fields where you just have, and technology in general, right? Because it's ever evolving, and you just have to keep updated, basically, right? Learning every day. So it's a never-ending learning journey, which I certainly enjoy. So the line between anomalous and expected behavior is often very fine and sometimes even has a significant overlap. For example, let's say we are a company based in the US. We expect to see almost all of our logins come from IP addresses in the US. One day, we get a login event from an IP in the EU, Europe Union, right? Which would be an anomaly. However, it could also be our CEO traveling for business, who's connected from there, right? This is an example where normal and malicious behavior intertwine, making it hard to create accurate detection rules that would not have too much noise. So blue teams constantly refine and improve their detection rules to close the gaps they experience due to the two reasons mentioned above. Let's take a look at how this can be done. So cyber attacks and the kill chain. Before diving into creating new detection rules, we first have to discuss some key topics. The first topic to discuss is the cyber kill chain, right? All cyber attacks follow a fairly standard process, which is explained quite well by the unified cyber kill chain. So it's initial reconnaissance, right? Initial compromise, yeah, establish foothold. After you establish foothold, you escalate your privileges. Then you do an internal reconnaissance, right? Then you move laterally if you wanna just basically move to another, maybe to another machine or another network. Then you maintain presence. Okay, and then the mission is complete, right? So as a blue teamer, it would be your dream to prevent all attacks at the start of the kill chain. So even just when threat actors start their reconnaissance, we already stop them dead in their tracks. But as discussed before, this is not possible. The goal then shifts slightly. If we are unable to fully detect and prevent the threat actor at any one phase in the kill chain, the goal becomes to perform detections across the entire kill chain in such a way that even if there are detection gaps in a single phase, the gap is covered in a later phase. The goal is, therefore, to ensure we can detect the threat actor before the very last phase of goal execution. That's right. So MITRE ATT&CK. This is a popular framework, right? For understanding the different techniques and tactics that threat actors perform to the kill chain is the MITRE ATT&CK framework. The framework is a collection of tactics, techniques, and procedures that have been seen to be implemented by real threat actors, right? The framework provides a navigator tool where these TTPs can be investigated. Let's check this out. This we can. All right. TTPs that can be investigated. However, the framework primarily discusses these TTPs in a theoretical manner. Even if we know we have a gap for a specific TTP, we don't really know how to test the gap or close it down. This is where the atomics come in. Okay, atomic red. The atomic red team library is a collection of red team test cases that are mapped to the MITRE ATT&CK framework. The library consists of simple test cases that can be executed by any blue team to test for detection gaps and help close them down. The library also supports automation, where the techniques can be automatically executed. However, it is also possible to execute them manually. So dropping the atomic. Max Skydy has a vague idea of what happened to the compromised machine. It seems someone tried to use the atomic red team to emulate an attack on one of our systems without permission. The perpetrator also did not clean up the test artifacts. Let's have a look at what happened. So running atomic. Max Skydy suspects that the supposed attacker used the MITRE framework technique this one, spare phishing with an attachment. Let's recreate the attack emulation performed by the supposed attacker and then look for the artifacts created, right? Opening up a PowerShell prompt as administrator. Okay, run as administrator. Enter the command get help invoke atomic test. You should see the output below. Okay, hold up, it's loading. The help above only shows what parameters are available without any explanation, right? Even though most parameters names are self-explanatory, let us have a quick overview of the parameters we will use in this walkthrough. So atomic technique. Explanation. This defines what techniques you want to emulate. You can use the complete technique name or the TXXXX value. These flags can be omitted. So example use invoke atomic test and atomic technique and which particular technique, right? Okay, show details shows the details of each test included in the atomic. Okay, show details. Yeah, makes sense. Show details brief. Shows the titles of each test included in the atomic. Check prerequisites. Provides a check if all necessary components are present for testing. Test names. Okay. Set the test you want to execute using the complete atomic test name. Sets the test you want to execute. Test gets, right? Set the test you want to execute using the unique test identifier. Test numbers. Set the test you want to execute using the test number. The scope is limited to the atomic technique. Then cleanup. Run the cleanup commands that were configured to revert your machine to state normal. Okay. our first command. We can build our first command now that we know which parameters are available. We would like to know more about what exactly happens when the test technique, when we test the technique T15666001. To get this information, we must include the name of the technique we want information about and then add the flag show details to our command. Let's have a look at the command we constructed. Yeah, the command we constructed, which is invoke atomic sorry, atomic test T1566.001, then show details, then path to atomics folder, which is okay, to atomics folder equals to tools atomic red team and then atomics. What? After atomic red team, then yeah. Okay, so what if we run this? A positional parameter cannot be found that accepts argument path to atmoxis path to atomics folder. Okay, let's check this out. It's path to atomics folder. That's correct. This command displays the details of all tests included in the T1566001. So this command displays the details of all tests included in the T1566001 atomic. Sure, but I'm getting an error here. Invoke atomic test T1566.001 minus show details path to atomics folder. What if we don't specify this and we simply provide the path? A positional parameter can be found that accepts. Okay, this failure might be caused by applying the default parameter binding. By invoke positional path to. Okay, let's keep going through this URL. Attack commands. The output above is clearly split up into multiple parts, each matching a test. Let's examine what type of information is provided in a test. We'll use the test we want to run as an example. Technique, phishing, spare phishing attachment, right? The full name of the MITRE technique that will be tested. Atomic test name. Download macro enable phishing attachment. A descriptive name of the type of test that will be executed. Then atomic test number. 1, right? A number is assigned to the test. We can use this in the command to specify which test we want to run. Atomic test get this particular value. A unique ID is assigned to this test. We can use this in the command to specify which test we want to run. Then description. This atomic test downloads a macro enable document from the Atomic Red Team GitHub repository, simulating an end user clicking a phishing link to download the file. The file phishing attachment.xlsm is downloaded to the temp directory. Provides a detailed explanation of what the test will do. And then, yeah, exactly. Attack commands, you can use executor is PowerShell, the elevation required false, and then the command, okay, this particular command. This provides an overview of all the commands run during the test, including the executor of those commands and the required privileges. It also helps us determine where to look for artifacts in Windows Events Viewer. Okay, cleanup commands, command remove item, environment temp, error action ignore, an overview of the commands executed to revert what is going on, to revert the machine back to its original state. Okay, then comes dependencies. There are no dependencies required, right? An overview of all required resources that must be present on the testing machine in order to execute the test. Phishing, spare phishing, okay. Invalid argument. Invoke atomic test. Isn't that the invoke? dash atomic test T1566. And then test numbers. Okay, let's just try that. Invoke atomic test T1566.001 minus test numbers 1 minus check prereq. Okay, something wrong here. Download macro enable phishing attachment. Okay, this command will use the data included in the dependencies part of the test details to verify if all required resources are present. Okay, looking at the test 1 dependencies of the T1566, atomic, no additional resources are required. So run the same command for test 2 and it will state that Microsoft Word needs to be installed as shown below. So let's run for test number 2. And then it should give us something like prerequisites for words found a command shell and used an IP address in the command. Not met, right? Words is found a command shell and used an IP address. Microsoft must be installed. Yeah, I see you. Microsoft must be installed. Yeah, okay. Now that we have verified the dependencies, let us continue with the emulation. Execute the following command to start the emulation. Invoke atomic test, and then T15. And then test numbers 1. I already ran that, and you should get the following output. Executing test, yeah, basically that's the output that we got, right? Download macro enable phishing attachment, and that the prerequisites were met. Invoke atomic test, yeah. Oh, wait up. No, I have to actually execute this path to atomic folder equal to C tools atomic red team atomics. Now the same problem as before. T1566.001 minus test numbers number 1 and then path to atomics folder equals C tool atomic red team atomics. Based on the output, we can determine that the test was successfully executed. We can now analyze the logs in the Windows Event Viewer to find indicators of attack and compromise. I mean, I see you, but I'm not executing this. Like, it's not running. So it says a positional parameter cannot be found that accepts argument path to atomics folder. This failure might be caused by applying the default parameter binding. You can disable the default parameter binding in PS default parameter by setting default disabled to be true and retry. The folder's default parameter was successfully bound for the command left when the error occurred. Path to atomics folder at line 1, chart 1. So what if I just execute this? Executing test, don't executing test, right? That's what we get. Oh yeah, I didn't have to specify that. That's just well, with the output of we get after executing this. So okay, let's keep going. That was my bad, guys. Based on the output, we can determine that the test was successfully executed. We can now analyze the logs in the Windows Event Viewer to find indicators of attack and compromise. So detecting the atomic. Now that we have executed the particular atomic, we can look for log entries that point us to the simulated attack. For this purpose, we will use the Windows event logs. This machine comes with system installed. System monitor, right? Provides us with detailed information about process creation, network connections, and changes to file creation time. To make it easier for us to pick up the events created for this emulation, we will first start with cleaning up files from the previous test by running the command invoke atomic test. Okay. We will start first cleaning up files from the previous test. Okay, so we want to clean up invoke atomic test space T1566.001. Now test numbers 1 clean up. Download, done executing cleanup. Now we will clear the system event log, right? Open up event viewer by clicking the icon in the taskbar. Event viewer. Where's that? Event viewer. Okay. So open up a viewer or searching in the start menu and navigate to the applications and services. And then we want on services logs. Is that it? Or maybe that is Microsoft. Where's Microsoft? Event viewer local. Navigate to applications and services. This one should still loading. Oh yeah, double click. Then we go to Microsoft. Then we go to Windows. Then we go to Sysmon. And then we go to operational. Sysmon, where are you? Sysmon, and then we go to operational. On the left hand side of the screen, click clear log. Right click on operational on the left hand, and then we have to clear lock. Clear when the pop-up shows. Click clear. Okay. Now that we have cleaned up the files in the sysmon logs, let's run the emulation again by issuing the command invoke atomic test. Okay, we can do that. Numbers 1. Right? Okay. We are executing that. We executed it. And now what? Next, go to the event viewer, right click on the operational log. Right click on the operational log on the left hand side of the screen and then click on refresh. Okay, there should be new events related to the emulated attack. Now sort the table in the date and time column to order the events chronologically, right? Oldest first. Do we see the oldest first? Yeah, sure we do. The first 2 events of the list are tests that Atomic executes for every emulation. We are interested in 2 events that detail the attack. First, a process was created for PowerShell to execute the following command. It's PowerShell X URL, specify the URL, you download a particular XLSM file. I mean, that's the URL where the URL is pointing to. Then we invoke web request -URI out file. And then you place them basically in this temporary directory. So then a file was created with the name phishing attachment, XLSM, okay? Click on each event to see the details. When you select an event, you should see the detailed overview of all the data collected for that event. Click on the details tab to show all the event data. So I click on a particular event. Oh, these first 2 are just, right? This happens for every, they said that this happens for every emulation attack. So yeah, we get something here. Invoke web request out file phishing attempt. Yeah, we found it. We found that information. Okay, navigate to the directory, see users administrator app data. Okay, let's go. So if we go to the directory, this PC, and then we go to users, administrator, app data, local, temporary, just this one, and open the file phishing attachment.txt. Open it. Okay. And then we get that flag. The flag included in the is the answer to question number 1. Okay, let's just copy all this. Let's just answer the question number 1. What was the flag found? Yeah. No. Let's get through this. Where are we? Okay, the flag included is the answer to question number 1. Make sure to answer the question now, as a cleanup command will delete this file. Okay, let's clean up the artifacts from our spread phishing emulation. Enter the command invoke atomic test. This one again. Okay, so we're gonna be cleaning up again. Okay, let's do it. Although I think I have it here, right? Clean up. Okay, we cleaned up. Now that we know which artifacts were created during the spear phishing emulation, we can use them to create custom alerting rules. Okay, that's a good point. Yeah, this could. I see how this tool could come in handy for blue team for people working in the blue team, right? Because they can generate new alerts. We will explore this topic further. Okay, so alerting on the atomic. In the previous paragraph, we found multiple indicators of compromise through the Sysmon event log, right? We can use this information to create detection rules to include in our EDR, CM, IDS, etc. These tools offer functionalities that allow us to import custom detection rules. There are several detection rule formats, including Jara, Sigma, Snort, and more. Let's look at how we can implement the artifacts related to T1566.001 to create a custom Sigma rule. Two events contain possible indicators of compromise, right? Let's focus on the event that contained the invoke web request command line. PowerShell this invoke web request, and then you save this generated node file, you save it in the temporary directory, right? We can use multiple parts of this artifact to include in our custom Sigma rule. Invoke web request. It is not common for this command to run from a script behind the scenes. Absolutely not. Then URL, a particular URL, attackers often use a specific malicious domain to host their payloads. Including the malicious URL in the Sigma rule could help us detect that specific URL. Okay. And then phishing attachment XLSM. This is a malicious payload downloaded and saved on our system. We can include its name in the Sigma rule as well. Yeah, makes sense. Combining all these pieces of information in a Sigma rule would look like something like this. On file creation of phishing attachment ID 1, description text the user should invoke request to download phishing attachment and the creation of file. Status experimental author TryHackMe log source category process creation Windows is one detection selection web request event ID command line contains invoke web request okay selection file creation event 11 system event ID for file creation. Okay, condition selection invoke web request or selection file creation file false positives. Okay, the detection part is where the effective detection is happening. We can see clearly the artifacts that we discovered during the emulation test. We can then import this rule into the main tool we use for alerts, such as EDR, CM, XDR, and many more, right? Now the glitch has shown us his intentions. Let's continue with this work and run an emulation for ransomware. Okay. As Glitch continues to prepare for SOCMAS and fortifies Warveil's security, he decides to conduct an attack simulation that would mimic a ransomware attack across environment. He's unsure of the correct detection metrics to implement for this test and asks you for help. Your task is to identify the correct atomic test to run that will take advantage of a command and scripting interpreter, conduct the test, and extract valuable artifacts that would be used to craft a detection rule. Okay, what AT&T key technique ID would be our point of interest? Command and scripting interpreter. Okay, so let's go to this particular website. ATT&CK navigator, create a new layer, open existing layer, help. Let's go to MITRE ATT&CK, leave page. Okay, so you're asking me, what AT&T and CK technique ID would be our point of interest for this challenge, right? So Glitch continues to prepare for SOC, wants to fortify Warveil security. He decided to conduct an attack simulation. It's a ransomware, right? Across the environment, he's unsure of the correct detection metrics to implement for this test, and as you've heard, we want to identify the correct atomic test to run, and that will take advantage of a command and a scripting interpreter. Command and scripting interpreter. Would this be impact? Nope. Let's check the hint. External research. Look up the MITRE ATT&CK ID for command and scripting interpreter. Oh, okay. What technique ID would be? Okay. I'm able to find this here. Supervision command. There must be search. Command and scripting interpreter. What is the ID? Command and script. This is the ID T1623. All right, we got it. Uh-oh, that's not the correct answer. T1623. Looks like that's not the one. Maybe this is the one. Yes, this is the one. Would be your point of interest. Okay, 1059. Okay, what if we go Command scripting interpreter technique enterprise. Okay. And what AT&T subtechnique ID focuses on the Windows command shell. Windows command shell subtechniques. Windows command shell. It would be this subtechnique of this. Then it would be the ID. Okay. What is the name of the atomic test to be simulated? The name of the atomic test. The name of the atomic test to be simulated. How do we find that? Alerting on the atomic. Basically, running an atomic. Invoke atomic test. Running an atomic. Suspect technique is phishing. Yeah, it's not the one. Command and scripting interpreter. Windows command shell. Is this the one? You're asking me for the name. Command. No, I don't think so. I don't think this is the one. What is the name of the atomic test to be simulated? So what is the name of the atomic test to be simulated? Don't know. Maybe I have to. What is the name of the atomic test? Atomic routine library is a collection of routine test cases that are mapped to the MITRE ATT&CK Framework. This library consists of simple test cases that can be executed by any blue team to test for detection gaps and help close them down. This library also supports automation, where things can be automatically executed. However, it is also possible to execute them manually. Xsky has a big idea of what happened to the compromised machine since someone tried to use the atomic routine to emulate an attack on one of our systems without permission. The perpetrator also did not clean up the test artifacts. Let's have a look at what happened. Get help, invoke atomic test, then name. You should see the output below. This defines what technique you want, show details. You can use the complete technique's name. Okay, so what if we go invoke atomic test, and now show the details of each test included in the atomic. Show the title of each test included in the atomic. Yeah, I think that's the one, right? So T, something like this, and after the T, show the title of each test included in the atomic. Show details, brief. Now let's get the particular T that we got. It was T1059. What's going on? Then, come on, start working already. 1059, 59.003. All details brief. Create and execute batch script. Create and execute. Writes text to a file and displace it. Undisplace it. No. Maybe suspicious execution be a command. Suspicious execution. No, this doesn't do. Simulate. Oh yeah, we have to simulate a ransomware, right? So simulate black byte. Let's check it out. Simulate black byte ransomware rank bombing. What now? So what is the name of the file used in the test? The name of the file used in the test. So you want me to run the test, right? Here. And then test numbers 4. Printing. What's going on? Could not start bring job. Okay. What is the name of the file used in the test? The file used in the test is atomic red team of the file used in the test. Don't executing test. The name of the file, would it be, how do I go about finding the name of the file used in the test? Let's check out our information here. Test's name. See the test you want to execute using complete atomic test name. This test name's download macro. Set the tests you want to execute. No, I don't want to set no test. I want to find out the name of the file used in the test. Atomic test name. It's not it. Test names, test numbers, test needs. Execution technique, test names, check prerequisites. File, check the title, show the details of each atomic test. Name file. Atomic test name. The full name of the MITRE technique that will be tested technique. Atomic test name. Script name of the file. A file was created with the name phishing. Oh, okay. I see you. So you're asking me for this, I guess, right? So first the process was created, so I guess I have to check out the particular. Okay. I would guess I have to clear the log, then cleared. Now we can run the test. Test numbers 4, executing the test, printing variables ransomware text on the Microsoft print pre or on port prompt. Ransom save. Okay. Now we click on refresh. Do we get some information? Looks like it. If we go to file version image, PowerShell, the name of the file, ransomware, Wareville ransomware.txt, right? Is the file to start WordPress, WordPad X, and then the name of the file. Wait, current directory. Yeah, that's the command line. So I would assume it's Wareville ransomware.txt. That's right. What is the flag found from this atomic test? What is the flag found from this atomic test? Well, I don't know. What's the flag? Atomic administrator. What is the flag found from this atomic test? How do I go finding one flag? I want to hit on the hand, but at the same time I don't. Glitch continues to prepare for SOC. Yeah, okay. He decides to conduct the simulation while doing ransomware across the environment. Okay. He's unsure. Okay, so I guess you created a particular file because they made us just basically name something. Ransom PDF. So what if I open that? Maybe the flag was stored here. Maybe. We'll see. Yeah, you see? I don't see. I want to see bigger. Okay. It looks like this is the flag. Glitch is working on testing the security posture before SOC mass, right? Is here. I will run as many tests and ensure we're all safe and uncover all threats before that hit us. Okay. Looks like we found the flag. Downloadable the Atomic Crack team via the linked room. I just want to check out the head, save the PDF, and read its content. Yeah, that's exactly what I did. Okay, guys, that's it for day 4. I'll see you on day 5. Cheers. We got this.